This video is going to cover why galvanic cells make electricity and not another form of energy such as heat. So this is part number 1 in my galvanic cell series, where I'll be addressing some common questions. And no prior knowledge is needed, but I recommend that you've watched my galvanic cell introduction video linked below just for some context. But anyways, let's have a look at a generic galvanic cell first, and how that makes electricity. So this is a typical zinc copper galvanic cell. In the left half cell, we have zinc solid oxidizing, so that means it's losing electrons. And then in the right half cell, we have copper 2+, accepting 2 electrons, so it's reducing. And for the electrons to travel from zinc to copper, because zinc is giving up these electrons and copper 2+ is accepting them, these electrons, they travel along the wire, which is also known as the external circuit, so you might see that word flying around. And the reason why this makes electricity is because, remember, electricity is defined as the movement of electrons, or charged particles, in a circuit. And a circuit is basically a pathway where electrons can flow through, such as the piece of wire that we have here. And that's why it's called the external circuit, because it's a path where electrons can move from the zinc half cell to the copper half cell. And this process of electrons moving along this wire results in electricity being produced. And this is why if you put a voltmeter or a light bulb along this wire, it would light up as a result of the electricity flowing through the system. Now, to understand why galvanic cells are set up like this, with 2 half cells rather than just one beaker, let's look at the case where we just have one beaker or one half cell. So I'm going to combine these 2 half cells into one. So the 2 electrodes, the wire, the voltmeter, they all stay the same. And the electrolyte is mixed because we've mixed the solutions from both half cells. So we have both zinc nitrate and copper nitrate in this one beaker. And just to make it clearer, I'm just going to represent the types of ions that we have in solution. So we have zinc 2+, copper 2+, and nitrate ions. And also, there's no salt bridge because there's actually no charge buildup, but that's not really important, so I'll focus on the important thing. So what's happening in this cell? Well, in terms of the half equations, it's exactly the same. So zinc is still oxidizing and giving up 2 electrons, and copper 2+ is still accepting those 2 electrons and reducing. So the first point is the same between these 2 different versions of galvanic cells. However, the second point is a bit different. In the first case, we have electrons traveling from zinc to copper along the wire, but this time, they don't all move along the wire. Instead, electrons are going to be directly transferred from zinc to copper. A way that you can think about this is that electrons are lazy. Why would they take the long route around the wire when they can directly give their electrons to the copper 2+ in the solution floating around them? And this is made possible because in the first case, there was no way for the zinc solid to give its electrons to copper 2+, apart from the wire, since the 2 half cells were physically separated, but now it's not the case. Now it can directly pass its electrons to the copper 2+, which is just floating around the solution. And although this results in the same products, a key difference is that no electricity is being produced. So although we have the transfer of electrons, one is an indirect transfer of electrons via the wire, so that was the first case. But in the second case, we have a direct transfer of electrons between zinc and copper 2+. And since we have a direct transfer, electricity is not produced because, remember, electricity is the movement of electrons in a circuit. And since the electrons in the second case aren't traveling in a wire or a circuit, there's no electrical energy produced. And instead, we have heat energy, which is expected because this is an exothermic reaction. And in fact, all spontaneous reactions in a galvanic cell are exothermic reactions. So to summarize and answer the question, why a galvanic cell makes electricity, there's two key points that you need to know. First is that the half cells are separated. So the zinc solid, or the reductant, and copper 2+, the oxidant, are physically separated. So there's no way for them to directly pass their electrons between each other. And the second point is that electrons are transferred via the external circuit, or the wire, rather than directly transferred. And the second point here is basically the definition of electricity. Cool. So that's why galvanic cells make electricity. And if you want to see my other videos on this topic, on galvanic cells, then make sure to check the links below, which will take you to videos focusing on the topics as shown on this screen.